As I said, there's data management protocols. This is a real-time data delivery system. It's set up now for real-time data delivery. So it can work in synergy with PACE and these other ocean color satellites to really support operational purposes. There's also delayed mode and QC data being delivered for science. And kind of goes without saying, but it's really providing the foundation to answer many of the critical processes for climate variability, ecosystem health, management, marine resources, carbon budget. We're getting full year time series of pH and oxygen and nitrate in places where there's never been observations before. So just looking at these data, just playing with them is incredibly exciting and really kind of mind-blowing when you're comparing them to what's happened in the past. This is the international steering team. Sorry for that. Steaming ahead. Web page. There's a ticker on this web page that tells you how much data is in the DAC in the Data Archiving Center for each observation. So I know that text is small. You can go to the website, but this is the number of oxygen profiles. It's updated in real time. Nitrate profiles, particulate matter profiles. It's really amazing all this data that's coming in, and the true measure that the success of a system is scientific publications. Basically, the people are using this, not just the PIs that are deploying these floats, but everyone is finding this data or starting to find these data and publish with them. And you can see over time how we've gone from very few publications to now, exponentially increasing. On the BGC, on the International BGC Steering Committee website, there's also communications, there's newsletters coming out, so you can stay in touch with what the community is working towards and get the updates. As I said, we've recently started a US BGC-Argo subcommittee, thanks to OCB. We met last year for the first time. And this is really a way to outreach with the community, to engage other stakeholders, and to help establish best practices and pave a path forward. And one thing that I'm very pleased about the subcommittee is we brought in a very diverse group of people. For example, my expertise is in mapping observations, not necessarily a biogeochemist, but I've been invited to join the group and think about how to use these data to assimilate into models or validate models or even just objectively map, and using information from the other forms of information like the ocean color satellites. There will be, now that best practices are really starting to become established, there will be a OCB-sponsored biogeochemical profiling float workshop this summer. Registration is now full, but I'm sure there'll be lots of documentation on this, and I'm hoping these kind of things will continue. This will be all about best practices, about preparing floats, processing data. So no matter where you're from, what you're doing, if you want to get involved and buy your own BGC-Argo float, you'll be informed. There's a white paper paving a path forward to how to implement global BGC-Argo. It's titled Towards a Sustained Program, Synergistically Interacting with Other Components of the Global Observing System. Argo provides TNS, but obviously it's part of a larger observing system, and it's become a vital part, and we want BGC-Argo to also become a vital part of the observing system. So let's see. There's a paper in preparation on Argo best practices that will basically pull together all the white papers and gray literature out there. There's protocols, there's handbooks, but to have it in one place and to have it vetted by the steering committees. So that's coming out in this, or that will be coming out in this best practices and frontiers in marine science. So a key to success is to be able to have IOC, International Ocean Committee, approval so that when these floats go into an EEZ, there's an established protocol for whether the measurements can continue, like, for example, temperature and salinity. There's been a formal request to include these 6 essential climate variables, these mature measurements, in the Argo process. And the decision is pending, but we haven't heard anything negative yet, so we're optimistic that soon the EEZ won't be easy issue, won't be a problem for BGC-Argo. So this is February 2018. You see BGC-Argo array really growing rapidly. Number of chlorophyll measurements, oxygen measurements being taken currently. It's really filling in. And like I said, these are year-round. In the Southern Ocean, there's no pH in the winter. Now since 2014, when these floats have been deployed, now we have pH year-round. And BGC-Argo has become the dominant source of open ocean biogeochemical data. There's now more BGC-Argo data than in this, 2001, 2010. You go to NODC or you go to the US GODE, download the ship profiles. This is the number of profiles you'll get. Whereas BGC-Argo is now providing about 15,000 oxygen per year, 5,000 nitrate per year, almost 2,000 pH per year, and year-round. Let's see. This is about the kind of a summary of what's coming out in delayed mode, real-time adjusted, yellow, not real-time adjusted. Basically the data stream is evolving. I'm going to go kind of quick given the time, but there's a lot of, like I said, this is research-based right now. There's not a one organization like Argo, like NOAA, who's paying for a global array. I know it's but there are a lot of PIs who are buying floats now. Here's 2 in the tropical Pacific. It's part of the TPAWS. There's 2 more projects that are going to be deploying here, 5 floats with O2 and Biooptics, 2 floats near Station Papa. And the big one for the US is SOCOM. We have 111 floats out right now, active in the Southern Ocean. We started deploying in 2004, about 25 a year. And so now we're up to 111. We have 32 more planned for the rest of the season. And we will hit 200 or we hope to hit 200. All is going well, so we should be at 200 by over the next few years until the project comes to its end. And it's really got some international growing. This is 2018 plans, so this is just this year. We have 20 from India. There's 19 by France. China has 12 and plans to buy more. So there's quite a international buy-in. But note that the sensor load is quite variable. Some only have an oxygen, some only have the optical measurements. So it's not uniform in terms of the full load, but there is international buy-in in terms of these sensors. And then we're really ready to begin to assimilate these, to make maps, as have been very useful for the physical oceanographic, provide background states. This is my role, and we have the machinery, the software to do data assimilation with BGC-Argo, and to synthesize it with the satellites and other observations. And this is pH so what you're looking at here is 2014, 15, or kind of cycling through, and the floats are being deployed. They're kind of hard to see. They're the circles with this like white ring around them, and the background's the model, the simulating model, an interim solution moving forward. And you really see the deployment of the array, and you see that we're getting pH at 50 meters year-round now. We're providing products that have pH year-round. We produced in 2008, 2012, 1/3 degree state estimate. Most of the floats only had oxygen back then. Now we are producing 2013, 2017, providing biogeochemical and physical budgets, extensive validation, analysis software, enabling researchers and stakeholders to understand the variability of our marine resource. This is work led by Ariane Verdi and myself. I'll talk a bit more about this product tomorrow. And I'll stop there, but I'll be part of the networking group. So I'll have a table and be happy to talk more about these floats and the sensors and the resource. Thank you.
Any questions for Matt? Okay, great.
Well, Can you tell me what the lifetime of the floats is?
Yeah, that's a great question. So it's the same as regular Argo. We have the Biogeochemical-Argo shell is larger, so they carry a larger battery. But it's really, it's pivotal, it's vital, it's necessary that we don't jeopardize the Argo physical measurement lifetime at all. So for every biogeochemical sensor that's added, more batteries have to be added. So these floats are getting 250 cycles, just like the typical Argo, and at 10-day cycling to 2,000 meters, which these are now programmed to do, they should last about 2,500 days or about 7 years. And the failure rate so far is about the same as with conventional Argo, core Argo. So they should be, we're trying to get the seasonal cycle large scale, so these should be providing observations at the same level, over the same lifespan as Argo.